This is Advanced Math, 4.6 notes. That's Unit 4, Lesson 6. The title is Graph, Tangent, and Cotangent. We're going to graph tangent and cotangent graphs is what we're working with today. Okay, we are going to graph number 1, y equals cotangent x. And there is the reason I'm starting with cotangent before I do tangent. So what I'm going to have you do first is make a t-chart. This t-chart we're not going to keep doing. We're only going to do it a few times, and after that we know what the graph looks like. I'm going to have you use your unit circle to figure out cotangent. Remember, cotangent is x over y. For 0, pi over 4, pi over 2, 3 pi over 4, and pi. So go ahead and hit pause, get out your unit circle, or if you have it in your head, and find x over y for these 1, 2, 3, 4, 5 points. All right, for 0, it is undefined. For pi over 4, it is 1. Pi over 2 is 0. 3 pi over 4 is -1. And at pi, you're back at undefined. Okay, so our period length does change for tangent and cotangent graphs. Instead of being 0 to 2 pi, it's 0 to pi. So what does that graph look like? It still starts at 0. It ends at pi. As you can see, pi end up back where I started. Half of pi is pi over 2. Half of pi over 2 is pi over 4. And midway here would be 1 over 4, 2 over 4. This would be 3 pi over 4. All right, now my start and my end are both undefined. My start is 0. My end is pi. Pi over 4 is 1. Pi over 2 is 0, and 3 pi over 4 is -1. Now we know enough about asymptotes that this graph is not going to be a straight linear graph going all the way through, because it can't touch those asymptotes. So what the graph ends up looking like, it actually curves like so, and does this, kind of like your negative cubic function, like the cubic function you did last year, but going in the negative direction. Only difference is the cubic function went on and got wider out like this forever. This one does get wider forever, but it stays between those two asymptotes, where the cubic function had no restrictions. It just went on to positive infinity or negative infinity to positive infinity for your domain. This one stays between those two asymptotes. All right, so there's your graph. That's what it's always going to look like for cotangent. And what we need to know is changing, and this is important, your period length for cotangent as well as tangent will always be pi over b. It is the only one that changes. Everything else is 2 pi over b, except for tangent and cotangent, pi over b. You do need to know that. All right, number 2, y equals negative CTN x. Whenever you see that, if you ever see it anywhere and they're asking you to graph and you're working with these cubic functions, just know that that is the same as negative cotangent x. This CTN, when you see it, it's negative, same as negative or positive cotangent. All right, let's go ahead and make our graph. And excuse me, I did make one mistake. I'm going to fix this here to be a 4x. Now, tangent is a little different from cotangent. Cotangent is just like sine and cosine as far as you start at 0 and end at your period. It's also the same when you do translations. You start at your horizontal shift and you end by adding your horizontal shift with your period length. Still the same. Only thing that's different is the way the graph looks and how you find your period. All right, so amplitude is still 1. Period is pi over 4, not 2 pi over 4, but pi over 4. And there's no vertical or horizontal shift. So I'm starting at 0. I'm ending at pi over 4. Now, technically, if I copied this graph, I would be here, but it's too small for me to show all my points, so I'm stretching it out. Half of pi over 4 is pi over 8. Half of pi over 8 is pi over 16. And because I start at 0, I can use my counters. 1/16, 2/16. This is 3 pi over 16. And 4 over 16 is indeed 4, or pi over 4. All right. And I know my start and end is always going to be my undefined. And because it's negative, the only thing that changes is it reflects across the x-axis just like it has in the past. So this is still 0. This one becomes -1. Again, reciprocal, I'm sorry, opposite of 0 is 0, opposite of 1 is -1, and this -1 flips up to the +1. So it just flips across the x-axis. So now it looks like your positive cubic function. Cotangent, negative cotangent. Now, technically, we typically only graph one period, but this graph does go on just like the sine and cosine graph. It doesn't oscillate, but it does go on forever, like it's going to do this here and here, and it keeps doing that over and over in both directions, the same type of graph. All right, I am going to continue. Number 3, y equals tan of x. And I'm going to give you a new t-chart. X and tan of x. I called it y over here, but technically y is cotangent of x. X, and then for y, tangent of x, and I'm going to give you negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. All right, so again, that was negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Go ahead and use your unit circle, put it on pause, use the unit circle. Tangent is y over x, find its values, and then hit play and see if we end up with the same answers. All right, undefined at negative pi over 2, negative 1 at pi over 4, negative pi over 4, at 0 it's 0, at pi over 4 it's 1, and at pi over 2 it's undefined. And that's for y over x. Okay, so let's go ahead and get ready to graph. Start is negative pi over 2, and my end is positive pi over 2. And I have a point at negative pi over 4, 0, positive pi over 4. So there are 5 key points, 1, 2, 3, 4, 5. And my start and my end are asymptotes just like they were with the cotangent graph. The only difference here is with the cotangent graphs, like I said earlier, you will always start at 0 and end at your period, unless there's horizontal shifts, in which case you treat it just like you would sine and cosine. So this graph, even though it looks different, is just like sine and cosine. Start at 0, end at your period. Start at 0, end at your period. Tangent is the one and only one that splits at the origin. Splits at the origin. Now, when we shift it and translate it, it'll split other places, but for right now, it splits at the origin. All right, at pi, well, let me mark my 1 and my -1. And over here, quickly, I talked about an amp. Technically, it's like a fake amp because there is no max and min. I go up forever and down forever. That just tells me right there to go up 1 and here to go down 1. That's really all it does. Okay. Back to this one. At the negative pi over 2, I'm undefined. Negative pi over 4, I'm -1. At 0, I'm 0. Pi over 4 is 1. Pi over 2 is undefined. We know it's not a linear graph, and it ends up looking just like your cubic function, only it's sandwiched between those two asymptotes. I cannot get any wider than those asymptotes. So that's what the tangent graph. So positive tangent graph goes in the same direction as your negative cotangent graph. All right, that's it for that graph. So number 4. Oh, and what's the length between negative pi over 2 and positive pi over 2? It is pi, which makes sense. 2 pi over 1 is pi. Now, as I stated earlier, we don't always graph all of them, but technically it does go on forever in both directions. It looks like this over here and over on this side as well. It goes on forever and ever, but that there is one period length. All right, number 4. Y equals negative 2 tan x plus 3. Nope, sorry, jumping ahead of myself. Negative 2 tan of 3x. Okay, so amp, fake amp, I'm still going to call it the amp, is 2. The period is not 2 pi over b. Please remember it's pi over b, so pi over 3. Now, here is what you do. You split it. Because it splits at the origin, you take your period length and cut it in half. Take a look over here. Pi over 1 is pi, and pi cut in half is negative pi over 2 and positive pi over 2. Pi over 3 times 1/2 is negative pi over 6 and positive pi over 6. We cut it in half, put one on the left side negative and one on the right side positive. And that's your start and that's your end. When you have vertical shifts, we'll add numbers to the start and the end, but right now there's no vertical shift. So we are going to split at the origin, going from negative pi over 6 to positive pi over 6. That's my start, that's my end. Start and end. Cut it in half, you get 0. 0 to negative pi over 6 cut in half is negative pi over 12. 0 to pi over 6 cut in half is positive pi over 12. And we have our asymptotes at the start. Negative pi over 6 and positive pi over 6. And just like this one, the middle is 0, and the negative sign switches things around. So I'm going to mark this up at 2, down to negative 2. And over here in my original graph, I went left and down 1, but since I'm doing the negative of it, I go left and up to the 2. Over here I went right and up 1, but now I'm going to go right and down 2 because that's the amp, and it looks like this. Got it? So your negative tangent looks just in the same direction as your positive cotangent. So you do have to keep track of them because they all look very similar. That's your picture for negative 2 tan of 3x. Okay, number 5. Y equals tan of x plus 3. Amp is 1. Fake amp. Period is not 2 pi over 1, but pi over 1. 1 is right there. So you have pi, and then you cut it in half to find your start and your end. This is your start. This is your end. Pi cut in half is pi over 2. So negative pi over 2 for your start and positive pi over 2 for your end. And we have a vertical shift of positive 3. Okay, so I'm going to put the graph down here. And I'm going to go ahead and put my markings up. 1, 2, 3, 4, 5. Okay. Negative pi over 2. Positive pi over 2. Those are my start and ends. Those could be my asymptotes. Negative pi over 2 cut in half from 0 is negative pi over 4. pi over 2 cut in half from the 0 marking is positive pi over 4. And we always do our vertical shift before we do the amplitude. 1, 2, 3, that's my fake axis. Amplitude is 1, so I'm going to go up 1 and down 1. So up to 4 and down to 2. All right, asymptotes are at my start and end, there and there, negative pi over 2 and pi over 2. My start and end are always the asymptotes. And then I have my key points, 1, 2, 3, 4, 5. Those two are asymptotes. My middle is always a 0. In this case, it is a fake 0. And because it's positive, I know I'm going in this direction, increasing, where this one is decreasing from left to right. So at negative pi over 4, I'm at, from here, going down 1, because that was my amplitude. From positive pi over 4, from my fake axis, I go up 1, and then I draw my graph. All right, so I went from my fake axis, left and down 1, right and up 1. Left, down 1, right, up 1, because that was my amp. All right. The next one I am going to do with you in class, but I do want you writing it down, trying it on your own the best you can. This next one is on the test, so it is one you definitely want to make sure you understand how to do. Number 6, y equals negative tan 3x minus pi. So there is a shift going on here, and I do want to start you off at least. Your amp is 1. It's negative, which means it's decreasing like that. That's what your graph is going to end up looking like. Period is not 2 pi over 3, but pi over 3. And you cut it in half, and you get negative pi over 6 and positive pi over 6. If you multiply this by 1/2, that's what you would get, pi over 6. And I do positive and negative because it's split. Tangents always split. Now here's the tricky part. That's my start, and this is my end. But because I have a horizontal shift, I need to take that into account. So that's what you're going to do. You're going to find your horizontal shift by setting that equal to 0. After you find it, that's what you're going to put here. Plus, I'm going to put it lightly and in pencil because you're going to erase it and put a number in there. Plus your horizontal shift. So calculate your horizontal shift. That's what you're going to add to negative pi over 6 and positive pi over 6 to find your new start and your new end. And then go ahead and try to graph it. And there is no vertical shift, so you don't have to worry about that piece. Find your horizontal shift and add it, start, end, and do your best to graph. That is it for this lesson.